Good evening, everyone.
Good evening, sir.
Good evening, sir.
Yeah, good evening. So, Sonal, you are there?
Yes, sir.
So you are starting?
Sure, sir.
1 second, we'll start recording and then you can, okay?
अरे राम घेऊन पटकन बसवायचं नाव दे.
Yes,
Should I go ahead?
please.
Good evening, everyone. Hope you had a good day. As you all know, we are gathered here for an advanced masterclass on application of artificial intelligence, machine learning, and deep learning in domestic and international business with a special reference to education sector. We have witnessed two amazing sessions by our esteemed guest in the past 2 days. So welcome you all to the third day of our program. Let's make this session an interactive one. Shukla sir, over to you.
Thank you, Sonal. Yeah, thanks a lot. So now we are beginning with the third day. I hope that we all have enjoyed a very good learning and we have renewed the earlier knowledge and we got something new by understanding the regression method. So before Mithun joins, I think we should take some. We should invite the participants and they can share their thoughts. Is it fine? Yes, Dr. Rabindra. If we'll let's interact with the participants and let them share some of their learnings, what they have learned in last 2 days.
Yes, sir. It's a good idea to interact with all the participants. However,
Yes.
we missed unfortunately the first day. Uh, yeah, yesterday it was fantastic, and for me especially, I refurbished my previous ideas, which almost forgotten in last 1 year. So try to gain as much as possible from this and wrote some of the information what said. Things are going like this. But however, once we start practicing, then it will lead to eventually good outcome from this Atal program.
Thanks, Dr. Ravindra. Yeah, so really it's very nice to hear that, okay, that you had a very good experience. So even because we are going to meet on Monday, so we have started preparing our lab and we have uploaded the different softwares, okay, like the R and the Jupyter notebook and also that we have started working on that. So like many of the participants is they are from the different places, so they need to understand the location, and those who have already they know the Kothurud location where they have to come in Irandwani. It's fine for them, but many of them would not be knowing. So now more interaction is required. So anyone else would like to share something and tell his or her experiences? Yes, please. Anyone? We have Ankush Kudale, sir. Are you there? Any participants can, okay, who was there and would like to share. Hembade, sir, you are there? Am I audible to you? Anyone who would like to share or give some reflection about the learning, whatever we had yesterday? It's open to
Okay,
any.
good evening.
Yes, please, please. Yeah, Pallavi ma'am.
Yeah, like first day we have seen the linear regression, and yesterday it was all about the logistic regression models. Basically, logistic regression is used for a categorical variables. Like only there are two types, two types of category, like pass, fail, yes, no, true, false. So for that kind of model, we use a regression analysis, logistic regression analysis. And for that, as first day we have seen, we were getting a linear line or linear one single line for the model, for linear regression. But yesterday we have seen like it was a S-shaped curve, that
Correct.
scuboid was we were getting that kind of shape on the graph. So it was all about like logistic regression analysis.
Th- that's
That's it.
nice. Nice
Thank
to
you.
hear, Dr. Pallavi ma'am. Yeah.
Yeah,
So
thank you.
in fact, it was a very good to learn that the yes model which we have learned. Okay, that is the all the values between 0 to 1, and then taking out uh,
Yes.
the results from that was very interesting. Even I too like that. Yeah.
Okay.
Yes. Yes.
I'm here. Good
Yeah,
evening,
Mithun
everybody.
sir. Good evening. Good evening, sir. Yeah. Yes. Yes. Yes.
So you look very dashing, as usual.
Oh, oh, yeah. Thanks a lot, sir. Yeah. So yeah. So whether Bangalore is raining or it's now calm.
It's raining, sir. There may be a few power cuts, so please bear with me.
Oh, sure, sure. Why not? Why not? Yeah. So yesterday, yeah, I was just taking the some reflections of the learning. I think yeah, it has been a very good 2 days. Everybody has enjoyed, and
Thank you so much.
yeah, yeah, yes, sir. Yeah. So once again, we welcome you, and without wasting much time, we would like to all would like to just listen from you something you can share, and you can do the experience sharing with all participants, sir. Now it's over to you.
Thank you
Kindly
so much, sir.
take over, sir. Thank you so
Thank
much.
you, sir.
Thanks.
Let
Bye,
me
sir.
share the screen. Thank
Bye, sir.
you. Thank you.
Bye, bye, bye.
Okay, guys, are you able to sort of see my screen?
Yes, we are able to see, sir, your screen.
Okay. So yesterday we discussed one of the classification models, um, which is a logistic regression model. Before that, we looked at linear regression model. Today, we'll be doing something else. We'll be doing something very different. And I personally find this very interesting, this particular algorithm. So we'll be looking at the second type of classification model. And this particular model is called as a decision tree model. It is called as decision tree model. Now, decision tree model has many benefits. It has many benefits. There are umpteen number of benefits that you can think of for a decision tree model. We'll be looking at this. Um, we can study this in depth. In fact, decision tree is the most interpretable model. And it can be used. It has wide variety of uses, particularly in BFSI, banking, finance services, and insurance. Insofar as my agenda is concerned, we'll be looking at what is a decision tree. That's the first thing. Why do we need a decision tree? That is the second goal. Third one is certain important terminologies that are specifically useful in the world of decision tree. Fourth one is basically advantages of using a decision tree. So any algorithm will have its advantages. And similarly, any algorithm will also have its disadvantages. So an algorithm will have both its advantages as well as disadvantages. So what we would like to do is basically look at both the advantages as well as the disadvantages of this particular algorithm. So one question that you might have, or usually one question that people have is, sir, if I can use a logistic regression for a classification problem and a linear regression for a regression problem, why is there a need for a decision tree? Right? This is a logical question which anybody would ask. Correct? Has this question come to your mind? I anyway have logistic regression. Why do I need to use decision tree? This is a question to audience. Has this question come to your mind? Dr. Sheru. Are you able to hear me, guys?
Yeah, we can hear you, sir.
Okay. Has this question come to your mind as to why should I learn one more algorithm that is decision tree when I easily have a logistic regression model? Let me just try to answer this question in the next slide. You can see here, I'll ignore this slide basically. Why decision tree, right? Why decision tree? It's simply because of the following two reasons. So your logistic regression is a typical right? But many times there could be non-linearity in the data set, right? When there is non-linearity, your logistic regression model fails. And secondly, logistic regression model and the output of logistic regression model that you get, the coefficients and such things are not so straightforward to interpret. It is not so straightforward to interpret the coefficients and such things. Therefore, people thought to model very complex and non-linear relationship, the operative word being non-linear, an extremely complex relationship, we need an algorithm. Secondly, the algorithm should give output, which is not a black box output. Black box means you do not know what is going on. It is like magic. Something will happen and something will come out. We don't need a black box approach. We need what is called as a white box approach. When I say white box, basically, we are referring to a model which is simple and explainable. So this is one of the biggest advantages of using a decision tree. That is, it is a explainable model. It's very simple, easy to understand, and it is explainable. These are the 2 points which go in favor of a decision tree model. Now, certain important properties of a decision tree model. Is this a supervised or an unsupervised learning model? This is again a supervised learning model, which means that I have a predefined target variable. Secondly, it is useful in addressing classification problems. I can classify. It works for both categorical as well as continuous data. One point while covering here, I said that basically nonlinear relationships are one thing. Second, in the case of binary logistic regression, yesterday we saw churners, yes or no, whether a person is going to churn or is not going to churn. Whether a person is going to churn or is not going to churn. So here we have what is called as a binary class problem. So many times we have what is called as a multi-class problem. Multi-class problem means what? Instead of just 2 categories, we may have 3 different categories. Correct? We may have 3 different categories. That is 3, or you can have more than 3 categories as well. Let us say you're trying to predict whether a customer is highly profitable, not at all profitable, and completely unprofitable. High profitability, low profitability, and medium profitability. Right? So when it comes to high profitability, medium profitability, and no profitability, you can't use binary logistic regression model, simply because binary logistic regression model is used to address only a dependent variable which has a binary class. But when we have a multi-class problem, logistic regression, typically binary logistic regression model cannot be used. Therefore, this is one more case wherein decision tree comes in very, very handy. So to come back to the feature slide, here is a supervised learning algorithm. It can handle classification problem. And one big advantage as far as decision tree is concerned is that your output variable can either be categorical or continuous. It can handle both these cases. This is the beauty of a decision tree model. It can handle a numeric dependent variable, or even if you give it a categorical dependent variable, it can handle both these cases. So that is great advantage of decision tree. So far, is it clear? Is it clear, guys?
Clear,
Okay.
sir.
Yes. So here there are two types of decision tree. What is called as regression tree, and the second one is what is called as classification tree. Meaning, I can use a decision tree for either regression problems or for classification based problems. Both of these things are allowed. Let's look at one particular sample use case. This is just a use case. To the left side, I think you can see a tree based structure. Can you see this?
Sir, your PowerPoints are not changing, sir, slides.
It is not.
As for me, sir.
I've changed it to a different slide now. Can you? I moved. Is
I
it the same for
I don't
everybody,
know
or is it?
about others.
And we are
No,
able to
sir.
see the we are able to see the
No, sir.
slide.
Okay. Okay.
Only it's not moving.
Okay. Now yes, next slide has come. Sample use cases.
Yes. Yes. Yes.
Uh, s-
Now
it is a sample use cases.
you're right.
Whether
You're
others,
right.
yeah, others are able to see this.
Yes.
Please confirm. Yeah.
Clear? Are you able to see this?
Yes, sir.
Okay. I'm just showing you a typical use case for a decision tree. This is how a decision tree looks like. But even before looking at this decision tree, look at the top node. Here I'm using amount of money spent. Amount of money spent is what? It's a numeric variable. It's not a categorical variable. Correct? So we can use a scale dependent variable here. We are allowed to do that. Correct? So if you look at the average amount of money spent, it is $399. The mean value is $399. So which means that a typical customer who comes is actually spending around $399. If I round it off, it becomes $400. Look at the shopping style. These are people who shop bi-weekly and buy in bulk. Bi-weekly means twice a week they buy. Correct? If you look at their behavior, the average spent amount is $378, which is less than the baseline amount of $400. So people who come bi-weekly and they buy in bulk, they're spending $378, which is less than $400. And therefore, I will be calling bi-weekly customers as low spenders. I am interested in seeing a number which is greater than $400. Let me look at the right side. Look at this. People who buy weekly and people who buy similar items. Correct? Their predicted amount is 405. Secondly, you can look at the second important predictor. Who are they shopping for? Let us say a person is shopping for himself and family. Look at the predicted amount. If the mean amount is $512. Is $512 greater than $400? $512, is it greater than 400?
Yes, sir.
Definitely 500 is greater than 400, which means that if You only look at the behavior of people who come weekly, but if he is shopping for himself and his family members, he is a typically very high profitable customer because his average spend amount is $512. If you look at those people who shop for themselves and spouse, they spend $391, which is less than the mean spend. So they're poor spenders. This is the conclusion. So this is how a decision tree can help you derive very complex insights in a very simple way. Now, to understand a decision tree, you don't need to be a great statistician. You don't need to be a great AI ML expert. You don't need to know too much about theory and such things. And that is the beauty behind a decision tree. It can easily, this is very, very explainable, easily, even a layman can understand this. And therefore, decision tree is more useful in many cases than logistic regression and linear regression model. So far, I hope it's clear. Is this clear?
Yes, sir, it is clear here.
Now I'll go back a couple of slides to the initial slide. Please tell me if you can see this. This is a pictorial representation of a decision tree wherein you have what is called as the root node, right? Here, if you split it, it is called as a decision node, right? If after decision node, one more node you may get that is called as a terminal node. A node is called as a terminal node because it terminates after this. After this, there is no other further growth. So you always look at the green boxes here because they are the terminal node, because after this, the split stops. You don't make a decision based on the decision node itself. That is like just looking at the intermission and saying that the movie is good or bad. It's not a good thing to just look at the intermission and say. You have to look at the whole movie. Whole movie means go all the way deep down and look at the terminal node. Correct? So this is what the first node is, what is called as the root node. This is the terminology. The first level of split you can call as the decision node. And if that decision node further splits, examine whether it is further splitting. If the split stops there, it is called as terminal node. This what we have put in a box is can be called as a branch or as a subtree, because this portion itself is acting like a tree here. So this is one of the ways in which you can construct a decision tree. These are some of the important terminologies. Is this clear? Is this clear?
Please repeat, sir, once. Yeah.
So I'm saying that the topmost box that you see right at the top, this is like a person's face or head. This is called as the root node. The terminology that we use here is root node. Now, if
Okay.
it splits into what is called as a decision node. The first level of split is what is called as a decision node. And if this decision node further splits, it is called as a terminal node, because after the terminal node, there is no other box that you see. It terminates, the tree grows and stops here. Similarly, if this decision tree can be further split, it leads to what is called as a terminal node. If it further splits, you can call it as a decision node. And if it does not split after this, you can call this as a terminal node. Is this clear? Is this clear, guys?
Yes.
Now let me just go here. So I'm just giving you an example here. This topmost box is what is called as the root node. This here is called as a terminal node because there is no further growth here. On the other hand, this box is called as it is called as the decision node. Finally, this box is called as a terminal node because the tree does not grow after this. I hope it is clear.
Yes, sir.
I've already introduced these things to you, so I'll just skip this slide. Now, there are two types of trees which you have seen. One is used for classification. Second one is called as regression tree. At a very high level, if you want to know what is the difference between these two. Classification, the dependent variable is categorical. Here, regression tree, the dependent variable here is continuous. because it's a prediction based problem. The dependent variable is what is called as continuous. The value obtained by the terminal node in the training data is the mode of the observations falling in that region. So in a classification, this problem, we typically use what is called as the mode to represent the entire box. But here when you're predicting the regression, if it's a regression problem, you just now saw the average amount is what is used, right? We're just using the average amount. So this is the difference between classification and regression tree. Now, don't worry about some of the other points. I'll just explain while going through the other slides. So far, is it clear?
Yes, sir, it is clear. Yeah.
For classification, the dependent variable must be categorical. For a regression-based tree, the dependent variable must be numerical. Now, certain advantages. This is a very important slide. It's easy to understand. You just now saw that how easy a decision tree is to understand. Second one is basically it is useful in data exploration. So a decision tree, you can use it not just for modeling, you can also use it for exploring purposes. So both these things you can do. Logistic regression is a model. You can't use it for data exploration. Linear regression is a model. You can't use it for data exploration. Next important point is there is less data cleaning required. Yesterday you saw we spent a lot of time in just data cleaning, right? We spent a lot of time in data cleaning and such things, right? But here when you're doing a decision tree, you don't need to sort of spend so much of time in data cleaning and such things. Fourth point here is data type is not a constraint. This is a beautiful point because many times when you're using a logistic regression model, the data type becomes important because dependent variable has to be categorical. But here, when you're using a logistic regression model, data type can be mixed. It can handle mixed data type. Last one is that it's a non-parametric approach. Non-parametric approach means there are no assumptions behind the data. Is this clear?
When you say no assumptions of the data, so can you just throw some light on that?
Yes, sure. So usually when I say no assumptions of the data, many times what happens is that if you're doing some of the methods, there are certain assumptions behind the data saying that the dependent variable should be normally distributed. That is one of the assumptions in linear regression, correct? Secondly, the independent variables should be uncorrelated because if there is correlation between the independent variables, the estimates that we obtain will be unstable. So here in the case of decision tree says, I don't care whether your data is normal, not normal, whether it is numerical, whether it is not numerical, whether it is mixed. I don't care. You just give me the data. I will do a deep dive into the analysis and I will pick up important insights and give you. So that's the reason why we say there are no assumptions behind the data. Normality assumption, variable should not be correlated. Those are all assumptions. Those assumptions are not there at all in the case of decision tree. That's what I'm trying to tell you.
Okay, sir. Yeah, clear. It's clear now. Yeah.
Okay.
Yeah. Yeah.
So it is useful for data exploration. Just think of it. Many times, you may not have good variables. Just sometime back, I was just working with a person. He had date as one of the variables. Only date he has. When was a problem raised? Let's say a ticket. There's in IT industry we call this as ticket. Let's say you're facing a problem with the laptop. You call up the IT service and you say, "Sir, my audio is not working." The ticket is raised on let's say first September, and it gets issued on it gets resolved on 3rd September. So ticket issue date is that ticket solved date is ticket issue raised date is that ticket resolved date is that. Only two date variables. Now, uh, when you look at this variable, what analysis will you perform? Because you don't have rich data, you don't have age like that, you don't have anything. Yesterday we had 21 variables. We are fortunate enough if you have so many variables. In real-time scenario, you'll have weak data. So the point that I'm trying to make is, when we have ticket open date and ticket close date, it is not very helpful. But what my suggestion to him is, just calculate the time spent between the open date and the close date. September 1, the ticket was open. September 7th, the ticket was closed. So take the difference, you'll get 7 days. So on an average, the team is taking 7 days to resolve. That's a new variable that we were able to create. So if the ticket is resolved on a Monday, we can, from the date variable, we can pick up the day, we can pick up the time, we can pick up the year, right? We obtained 3 or 4 variables. So a good AI ML expert is not somebody who knows all the algorithms properly. A good AI ML expert is a person who is able to create new features, who is able to derive new features and such things. If you are able to do that, there is nothing like it. Therefore, we are saying it is useful in exploring the data, not just as a modeling technique. You can use this just as an exploratory technique. Look at this technique. You can just present this to the top management or anybody as a data exploratory technique, right? What are the insights? Look at shopping style. People who come twice a week, they tend to be not profitable. On the other hand, people who come weekly and who basically shop for themselves and family tend to be more profitable. Look at this next box. People who come weekly and who purchase for themselves and their spouse, they again are not profitable. People who come weekly, but people who shop for themselves, and if their gender is male, again they're not profitable. These are all very, very important insights. So decision tree can be used as an exploratory technique, as well as you can use this as a modeling technique. This is the kind of flexibility that decision tree brings to the table. So that is the reason why I'm sort of emphasizing here that it can be used as a exploratory technique. So far, is it clear?
Yes, sir. It's clear here.
Okay, if this is clear, let me just make a move on. What are the biggest disadvantages? The biggest disadvantage is that it can create overfitting. Overfitting problem means what? Overfitting problem means in a training data set, usually in the decision tree, you'll get high percentage of accuracy, let's say 90%. But the same decision tree, if you implement on test, you may not get 90%, you may just get 60%. So this is the problem of overfitting. Training and testing results will be inconsistent. This is the biggest disease with decision tree. I'm saying here it is not fit for continuous variables. Actually, it is fit even for continuous variables. But usually what happens is that when the dependent variable is continuous, people do not use decision tree mostly. They prefer to use linear regression and such things. Okay, is this point clear?
So please repeat once. Yeah.
Overfitting is a problem when the training accuracy is extremely high. Let's say 95%, and the test accuracy is basically, let's say 60%. There's a big gap in the accuracy between training and test.
Somebody's again asking overfitting.
Overfitting. Okay, I'm just explaining this point. So yesterday when we built the model, we in general in machine learning, what do? We build the model on the training and we apply it on the test. Correct?
Yes.
Usually what happens is in the training, the model will give higher accuracy. Let us say you may get 90%, but in the test, the accuracy may collapse from 90 to 60%. So it is very inconsistent, right? 90% in training, 60% in test. So the gap between training and testing cannot be so high as 30%. Usually, if the performance of the model in training and test is very consistent, let us say 4% and 5%, if it is very consistent or close to each other, then you can say that the model is reliable. Else, you'll say that the model is not reliable or inconsistent. So this problem of inconsistency in the performance of the model between training and testing is what is called as overfitting problem.
Clear, sir. Yes.
Okay, let me just make a move. How does a decision tree decide where to split? So here, let me just go back to this example. Here, shopping style, it decided to split first. Then, basically, it decided to split based on who are you shopping for, and then gender. You can ask me, sir, why not gender? Why was gender not first put first? That's a good question. Why can't we split based on gender right at the top? Then after gender, basically, why should we use some other variable? Why not we use, who are you shopping for? Why is that the hierarchy is basically shopping style first, then basically who are you shopping for, and then gender, right? So there is a method in this madness. What is that method in this madness that decision tree uses to split? Let me just explain this. So this slide we have already seen, so I'm just rushing through these slides. See, at the back end, the algorithm uses any of these four metrics. It can either use a Gini's method, or it can use a chi-square statistic. Third variable is it uses a information gain, or the fourth one is basically it uses a reduction in a variance. So the fourth method is applicable, that is reduction in variance is used if the dependent variable is continuous. Else you can use one of the three methods, Gini or chi-square or information gain. So based on these four methods, the algorithm decides where to split and how to construct the decision tree. Are you able to understand?
Yes, sir.
At the backend, this formula is used. Just remember it like that. At the backend, there is a formula. If the relationship between, if the chi-square value between the dependent and gender is very high, so gender will be used as the first best predictor, right? Let's say if the chi-square value between the dependent variable and another variable is slightly lower, it will not use gender as the variable. Whichever has the highest chi-square value, it will go by that. So these are the four methods. Okay, we can just ignore this. Okay, now let me proceed to show you how decision tree works. Shall I show the lab? Shall we go to the lab, please?
Yes, sir.
Okay. Okay, just give me 1 second. I'll close off some of the files which are unwanted and which slightly are distracting. So please tell me if you're able to see this file.
Yes, sir. We are able to see.
Okay, this is a famous file. You can always get this in the net as well. It is called as the iris dataset, right? And it's actually basically a good problem to understand and to understand, uh, how decision tree works. I'll show this decision tree in two different ways. One is basically I'll show this using Google Colab. Secondly, I'll use a proprietary tool, IBM SPSS, also to show you how a decision tree works using another data set, BFSI data set I'll use for that. But firstly, you have flower characteristics. Species of flowers have been taken, and you can see there are three different species of flower. One is what is called a setosa. This is the first flower, which is setosa kind of flower. Let me apply the filter Alt DFF. So you have setosa, you have versicolor, and virginica. So these are the three different types of flower that we have. So this is what will be my dependent variable, correct? This variable, species of the flower, will be my dependent variable. Now, how do I want to predict whether the flower belongs to Setosa species or versicolor or virginica. There are four independent variable. First one is what is called as sepal length. Next is what is called as sepal width. Next one is what is called as petal length and petal width, which means that based on the characteristics of the flower, like sepal length, sepal width, petal length, and petal width, I would like to classify whether the flower is iris setosa or whether it is virginica or whether it is uh, something else, right? So as you can see here, the dependent variable here has how many classes? Setosa, versicolor, and virginica. How many classes do you think the dependent variable has? Any idea?
Sir, what is the question, sir?
So in the dependent variable, how many classes you have?
Three classes, sir.
Exactly. So this is a typical problem of multi-class. So when you have more than two classes, your logistic regression becomes very difficult to use. So don't use logistic regression. So in your whenever you have a multi-class problem, a decision tree is best useful. Okay. So can we use this data and shall I show you how decision tree works? We first close the file.
Sir, what is the third one, sir? Class, Satosa?
Setosa, versicolor, and virginica. Virginica. These are the species of flowers.
Okay.
Okay. Even before this, let me just take a very simple problem. I want to take a simple problem to tell you how. Okay, I just want to tell you how versicolor, how decision tree works through an example, through a small example. Okay, now this small example is nothing but let me just also open up a blank PowerPoint so that I can tell you how decision tree works. Are you able to see this small data set?
Yes.
Right?
Yes, sir. We are able to see. Yeah.
Yes. So here is a very simple data set. I'll highlight the dependent variable. The dependent variable is whether a person has been a defaulted borrower. He has taken the money and he has failed to pay. So if he has failed to pay, I'll just call him as a defaulter. If he has not failed to pay, I'll call him as a non-defaulter. And I have certain characteristics of each individual. The first person is a homeowner. Y means he's a homeowner. No means he is not owning a home. S means he's single. M means married, and D means divorcee, and his annual income is also given. So these are my independent variables, and I've taken a very simple example of 10 cases. I want to predict whether a person is a defaulted, whether he's a defaulter or not. So by the help of this data set, can you tell me whether a person will be a defaulter or not? Just by looking at this data set, can you tell me what is the profile? What are the characteristics of a typical defaulter? Can you tell me something? Is it even possible for me to, if somebody comes and tells you, sir, I'm a homeowner, I'm married, and my annual income is $125, whatever, can you classify him as a defaulter or as a non-defaulter?
Yes, sir. He is, sir.
How?
I couldn't able to see your full data, sir. Now it's not on the screen.
Others are able to see? Are you able to see my data set?
Yes, it is on the screen.
Yes. So the question is basically based on his characteristics like homeowner, marital status, and annual income. Can I predict whether a person will be a defaulter or not? Very difficult when you look at the data set. So when I say data set, what is a data set? It is just a fact table. It has a set of facts and figures. I can't, looking at the data set, I think somebody has to put, somebody has to go on mute. Anyway, so looking at the data set itself is very difficult to follow whether a person will be a defaulter or a non-defaulter. Then what do? I'll just apply a simple Excel filter. Just look at this. I'm just going to apply a simple Excel filter. So I can just go to data and choose the option filter here. Now this filter option has come. Let me choose homeowner. I'm just going to go to the drop down menu and choose the option yes. Right? On the independent variable, I'm just focusing on the independent variable. I'm just looking at homeowner equals Y, which means that he is a homeowner. Look at this. So if a person is a homeowner, now look at the impact on the dependent variable. All of them are non-defaulters. Are you able to understand this? There is no mathematics, there is no hi-fi Gini's coefficient, there is no chi-square, nothing. I'm just applying a simple filter here. If the person is a homeowner, then basically you can see here, there is complete homogeneity. All of them are non-defaulters. So I can use this piece of information to construct a decision tree. How? Just go to insert. In this is PowerPoint, right? I can just go to insert and I can basically go to smart art, right? I don't have to do much here. I can just say hierarchy. You can see something like a decision tree will appear here. Now using this decision tree, or this also you can use. Just look at this. The first variable is basically we are trying to find out whether a person is defaulter or not. So this condition is basically that he is a homeowner, right? If a person is a homeowner, then what does this lead to? If a person is a homeowner, homeowner equals yes, then basically we can say that that particular individual is a non-defaulter. It's something like a tree. Let me go back to the data set. Let me remove the filter here. Instead of choosing Y, let me choose non-defaulter. I hope you're able to see my screen. Are you
Yes.
able to see the screen? Right. So here from homeowner equals Y, I've changed it to N, which means he is not a homeowner. Now, can you say anything? Now, in the dependent variable, you're seeing a mixed category. You're able to see no as well as Y. So this is a heterogeneous class. We want to be able to maximize the homogeneity of the dependent variable and minimize the heterogeneity, which means that when a person is not a homeowner, it is not this is where I will move to the second independent variable because one variable itself is not sufficient. I have to make a move on to the second independent variable, namely marital status. So for marital status, I'll remove all and look at only single people. Look at this. He is not owning a home and he is basically single, right? What do you see here? Again, a mixed category, which is not very helpful. So now, instead of the single, what are you getting? You're getting a homogeneous category, correct? Only non-defaulters. Is either married or let us say, let me just experiment. I'm just doing an experiment, right? If I include divorced, I'll get a heterogeneous category. So it's better to kick out divorced people, correct? So if a person is not a homeowner and he is married, marital status is M, then again, non-defaulters is what you're able to see. So you have obtained your second rule here. You can come to your PowerPoint and you don't need any algorithm and such things. You can say homeowner, homeowner equals what? Equals N. And basically marital status equals M. Marital status equals married, right? What does this lead to? This leads to all of them being, right? This is a person being married, right? Let me just click on enter. I wanted this to go down. Marital status. This implies. I'll just write implied sign. This implies that people are non-defaulters, right? A very crude way of doing a decision tree here, correct? Non-home owners, people who are married, mostly they're all non-defaulters. On the other hand, if I look at the profile of divorced people and single, you have already seen here that you're getting a heterogeneous category, which means what? Information is not sufficient to classify a person as defaulter or non-defaulter looking at only two variables. That is where I will look at the third variable, income level. So let me choose these two categories. Just experimenting with 70 and 80, you can see here non-defaulters. Just take a look at this. If a person is not a homeowner, he is single, and his income level is less than $80,000, he is not a defaulter. On the other hand, if I remove this filter and apply 85 and 95, the remaining class, I'm getting defaulters, which means I've been able to predict the behavior of defaulters. That is, they are not owners of home, they're either divorced or single, and basically their income level is on the higher side, then basically they tend to be defaulters. Is this clear? So there is no simple machine learning and such things. It is just simple filtering. Now you may ask, sir, okay, fine. This is fine because you had only 10 rows. You are able to do it. You are absolutely right. For the purpose of demonstration, I just took 10 rows. If you have millions of rows and if you have 30, 40 variables, independent variables, you can't apply Excel filter for 30, 40 variables, right? So you can't apply Excel filter. Therefore, you need an algorithm. What is that algorithm? That algorithm is either a chi-square test, or you need a Gini's coefficient, or you need information gain. Using that formula, this decision tree will be constructed. So here I've tried to construct a decision tree. You can see here, this looks something like a decision tree, right? It may not
Mithun
be
sir,
very, yes.
before you move ahead, Mane sir has put a question: how to identify dependent variable and non-dependent variable,
Okay.
or how decide which variable is dependent or which is
Okay, let me answer
not.
this question.
Yeah, sir, please.
Understood. Okay. How to identify whether a variable is dependent or not dependent? That
Yes, sir.
depends upon the business problem or the research goal that you have. So when somebody gives a data set to you, just ask a simple question. ID I can't use as a dependent or independent. You can just delete it. So here, homeowner is there, marital status is there, annual income is there, and default whether a person is, whether a person is defaulter or not. That information is there. The question is basically what should I choose as the dependent variable? Now go back to the objective behind the analysis, the research objective behind the analysis. If the research objective is to identify the profile of defaulters, I'll repeat, if the research objective or the goal or the purpose behind doing the research is to find out the profile of defaulters, that is the variable of interest. Defaulters, that is the most crucial variable that you are interested in. So choose default as the dependent variable, because your entire research is based on understanding who is a defaulter, who is not a defaulter. Yesterday, when I chose, let us say, churn, right? My goal there was to identify who's a churner and who's not a churner. My goal was to identify what is the profile of churner or non-churner. Now, sir, why can't I choose annual income? Ask yourself a simple question. Are you trying to find the profile of annual income? Usually, we do not need such a we are not interested in identifying the profile of who is low income people and who's high income people. If the research objective is to identify the profile of high income people and low income people, then you can choose basically low annual income as the dependent variable. So the short answer to your question is, what is the dependent and what is the independent variable completely depends upon what is your business objective or what is your research objective. If your research objective is to identify the profile or characteristics of defaulters, right, then choose that particular variable as the dependent variable. whichever variable is of interest to the researcher, that becomes the dependent variable. Does that answer your question?
Yes, sir. He replied, yes, understood. Yeah.
Okay. Now, did you understand this algorithm which I was just talking about?
Um, Pramod sir, you can reply.
Yes, sir, I understand, sir.
Yeah, yeah.
Hello?
Yes.
Yes, sir, I understand, sir. Thank you, sir.
Okay. No problem. Now, I'll just close this. This was just an example to tell you how decision tree works. I just want to move on to Google Colab and show you how decision tree can be constructed. Let me close this file. Now, Google Colab is very friendly in the sense that you can use this. Can you see my Google Sheet? Just a Google page I've opened. Can you see this Google? I've just opened Google search here. Are you able to see this?
Yes, we are able to see.
All right.
Yes, sir.
So in Google, anybody can do this. You can just go to Google and just type Google Colab. Right? Google Colab. My spelling is wrong. Google Colab. Right? So, or you can just show results for Google Colab. It says, welcome to Collaboratory. Let me just click on this. You just need to have a Gmail account, nothing else for this. Right? The advantage here is that you'll have a lot of, space here. It's easy to work. It comes in with a lot of pre-installed packages and such things, so you don't have to install this again. If these are some of the these are some of the notebooks that I had created, I don't want to use any of these things. I just want to create a new notebook. Are you able to see this? This is the interface of Google Colab. So it works just like Google Colab itself. You don't need to install any Anaconda and such things, right? This is a place wherein you can just go and type your codes here, right? So untitled 18, this is the name of the file. So here I can just tell you that we will be working on decision tree using the iris dataset. Iris dataset. So shall I begin typing the codes, guys? Right. I'll close all the unwanted things. This is just to show linear regression. I don't need the code. So this is my code. Okay. Now, okay, let me just come back. Right. Let me freeze this so that you're able to see only Google Colab and you don't get confused with the codes and such things. This is my Google Colab. Please tell me if you're able to see Google Colab. Are you able to see this? I'm zooming it in. Can somebody confirm if you're able to see my Google Colab?
Yes, sir.
Okay.
Yes, we are able to see.
Okay. So firstly, I can just install some of the packages. Some of the standard packages are there. What are the standard packages? I want to install pandas. Next is basically I want to install sklearn.datasets as datas. So by importing this, basically it will give me a it'll download a lot of data sets. It will download a lot of data sets. Iris dataset is already inbuilt into sklearn, so I will just work on this. Then from sklearn import tree. Why tree? Because we'll be doing a decision tree. And from sklearn.model selection import train test split, because we will be splitting the data set into training and testing. So all that you need to do is basically click on this arrow. The moment you click on this arrow, basically the code will be run. So if your code has run successfully, it will put a tick mark, else it will put a error, right? So the first piece of code of installing the packages is done. That is, I'm basically installing pandas, scikit-learn. That's what I'm doing. Okay, let's keep this discussion going. The second thing is basically I want to install, I want to download, I want to load the iris data set, correct? So you can see here the second line of code I'm saying import sklearn.datasets. So scikit-learn itself comes up with a lot of data sets. They've given 3 data sets. From this, basically, I will be loading the iris data set. So I'm just saying datas dot load underscore iris. This I'll be saving as an object iris data. So let me just go ahead and execute this. You can see here. So I am saving this as an object iris data and I'm displaying iris data here. Can you see this here, everybody? Can you see this?
Yes, sir. We are able to see. Yeah.
So it is not very clear here. It just means that basically the first flower, the first flower has a sepal length of 6.9. It may have a sepal width of 3.1. It has a petal length of 5.1 and it has a petal width of 2.3, right? And the target is given as 0. 0 is the coding for the first set of flowers, which is basically the basically the I think versicolor. That is just the notation 0, 1, and 2. That is the notation they have given. You can see here the data is not easily comprehensible. It is not understandable because the second set of flower has certain characteristics. So ideally speaking, this is what is called as a list, right? The list can be converted into a pandas data frame, right? So pandas data frame gives you a spreadsheet like view, and once the data set is like a spreadsheet, then it becomes a lot easier for us to do any data science, machine learning, and such things. So iris data which we have directly loaded is not in a usable format. So let me just bring this into a usable format so that I can run my machine learning and such things on this particular data set. They've given a lot of description and such things. We'll just ignore this for time being. Now, let me just check the data type of this data. This is sklearn.utils.bunch. Not very helpful, not very useful for us to do any analysis. Now, what I'm going to do is this data set comes with keys, correct? So I have to just type in the name of the data set, that is iris data dot keys of. What are the keys that are present in this data set that the author has provided? You can see here, if you want to see the data, these are the dictionary keys. You can just type iris data dot data and display the data. If you want to check the target, just type target. If you want to see the frame, this is the frame. If you want to see that, get the description, just type this code. So based on these inbuilt dictionary keys, we can control the data set. So some of the things, let's say, for example, I want to see the description. So all that I need to do is just type iris data dot descr. I'm just copying this word here, this command, description. The moment I execute this, it just gives a description of iris dataset. You can see here what all things are there here, right? It is just telling you about plants, some of the colors, right? The minimum, maximum, everything it is able to give you. Okay. Now, what I'll do is basically, this is not very useful. So let me just check the target of in this case. So when I just basically go here and look for the target, look at the way the target is there. You have 50 zeros. After that, you have 50 ones. And then basically, in the end, what you have is basically all the twos. It is just a notation for the 3 species of flower: versicolor, virginica, and setosa. The order is setosa, versicolor, and virginica. I think setosa is coded as 0, versicolor is coded as 1, and virginica is coded as 2. This is just a display. I'm just displaying the target variable as of now. Let us just keep going and see what we have after this. We will collect all the variables and store it as an object. Okay. Here the code is iris data dot data. I'm just creating my independent variables now. right? All the four independent variables will be created and it is saved as the object iris int data. Now you can see what I'm going to do is to convert into a pandas frame. So convert the object into a pandas data frame. Use pd.data frame, open bracket, pass the data set and save it as an object. Let me now display the first 5 rows. So are you able to see how it looks now? This is how it looks now. The first flower, these are the characteristics. Second flower, these are the characteristics. And when I go up, you can see earlier how the data was. Earlier, the data was like this. It is in the form of a list, right? Which is not very user friendly to understand. Now that we have converted this into a data frame, it looks like this, right? Again, you can see here 0, 1, 2. These are the column heading. It is not meaningful. We have to further work on the data set so that it becomes more meaningful. So far, are you clear with what we are doing? Are you clear with what we are doing?
Yes,
Sir,
we are
just
clear.
show the command for this conversion.
I'll show it to you. pd.dataframe, pandas.dataframe, open bracket, I'm passing the data set I'm as an object. It's a data frame with shape 150 rows are there, 4 columns are there. I hope this is clear.
Yes, sir. Yes, sir.
Right? So it is good, but not good enough. But at least I'd like to put some labels here in the column heading. I don't want to see 0, 1, 2, 3. This is meaningless. We would like to see column headers. So let me just put some heading so that it is more meaningful and comprehensible. So for this, let me see what all features are there, which the author of this data set has given. Iris data.feature name. So these are the 4 variables. You're familiar with this. Sepal length is there, sepal width is there, petal length and petal width is there. So these are the 4 variables that I have. Now, what I'm going to do is basically, I want to create a list of these 4 columns and label it as the header. Now you see the beauty behind this, how it looks, correct? You can see here the first column is sepal length. So the first flower has a sepal length of 5.1 centimeter. Second one, the first flower has a sepal width of 3.5, petal length is 1.4 and petal width is 0.2. These are the characteristics that we have. Now, if you go up above, you see how it is 0, 1, 2, 3, not very understandable. Now that we have put a label, this is a typical pandas data frame. We human beings, we machine learning experts, we can understand this, we can connect to this. We can't understand what is earlier, right? So all these things, what we have done so far is not to run any machine learning. We have just loaded the data set and we are trying to bring this in a usable and a comprehensible format so far. So far, I hope this is clear. Is this clear to everybody?
I think if some part of it can be repeated. So if anybody would have missed, will.
So you can see here basically, I have loaded the data set. In the third step, basically, I have loaded the data set. What is the command to load the data set? Load underscore iris off. I'm loading the data set and saving it as an object iris data. So to display it, you have to just type the object name and click on this arrow. The data set will be displayed. So this is the initial part that I've worked on.
Correct.
Check the data types. You can just type of iris data. So it says sklearn.utils.bunch. Don't worry too much about this. My goal is to basically bring this into a usable format. So just type the name of the data, iris data. set, he himself has packaged this, given it as a package wherein he has created dictionary keys. I am asking Python to display all the dictionary keys so that I can access. What is the meaning of access? If you want the data, just if you want to see the data, just type iris dot data dot data. If you want to see the target, just type iris data dot target. If you want to see this as a frame, iris dot data dot frame. Like this, you can use the dictionary keys to control the data set. Further, to just explain, what I've done is I've just typed the name of the file and used the dictionary key description, right? DESCR in caps. So what it does is basically it gives me a description of the data set. I'll just ignore this description because it is not very understandable, right? Second dictionary key is target. So if I type iris data.target, all the target values are displayed here. Further, I'm collecting the iris data.data as independent variables. I'm converting this as a pandas data frame. After collecting this as a pandas data frame, when I display the data set, this is how the data set will appear. It is good. It is better than the previous version, but the column heading is 0, 1, 2, 3. What is the meaning of 0, 1, 2, 3? I don't know. God alone knows. So what I'm doing is I'm trying to label each and every column. How to label each and every column? Iris data.feature names, when you do, the author has created the list of features as sepal length, sepal width, petal length, and petal width. He has put this in a list. Correct? The same list I'm using, I'm just putting this as iris in data.columns. Now, when I do the head, you can see here labels are being displayed. So this is a very user-friendly format, right? Pandas data frame we love because it's a user-friendly format. I can see the column heading. I can see the rows properly, right? So this is the kind of work that you need to do before bringing this into a usable format. Now we have brought it at least in an understandable format. This is how it is now. Originally, how was the data? You can see here, originally the data looked like this. Not at all easy, not at all user-friendly, not at all interpretable. Now that we have converted into a data frame, it has come to a usable format. So far, if it is clear, I'll just proceed.
Yes, it is clear. One more question is coming that can we create our own data set and how to add in coding and how get what we need as outputs?
Yes, you can create your own data frame from the scratch, but I would not advise you to code this. You can, there are multiple ways in which you can create your own data set through coding. I can share a few videos, but I would always say if you want to create your own data set, start with a spreadsheet. A lot easier to enter. You'll save a lot of time and such things. And then you can import the data set. That's a lot easier for you rather than coding the data set itself.
Thank you, sir.
Okay. Now, what the data set is ready. Now that the base data, this is called as base data because this is the data set on which the model will be applied. Now that the base data is ready, now you're ready to analyze the data. How do you analyze the data? First thing that you need to do is basically split the data. Now this is in our control. Now it is the old story that we have used. What is that old story? Split the data set, right? 80% to training and 20% into test. You're familiar with this functionality from day one. We have been using train underscore test underscore split. This is the name of the data set. This is the target. Test size is basically 0.2, which means basically 20% will be used for training. 80% will be used for testing. You can see these are the 4 objects that I've created. Independent variables for training, independent variables for testing, dependent variable for train, and dependent variable for test. I've created my data set now. My data set is ready. Next is basically a procedure which is called as instantiate. Right? We are instantiating the model. Very simple. You can see here tree.decision tree classifier. Remember, it's a classification model because the outcome variable is the type of flower or the species of flower. Either it is setosa, versicolor, or virginica. Because we have the outcome variable as species, I am going to use decision tree classifier. Else, I would be using what is called as regressor. Maximum depth is 4. You can change it to 3 or 4. You can experiment. Criteria is entropy. What is this entropy? Entropy is a measure of disorderliness in the system or chaos in the system, right? So what we want is a decision tree which helps us make a journey from chaotic and more orderly, right? So this is basically a case wherein I'm just instantiating the model. That's it. I'm not applying the model. Next step, I can use the fit function to apply the model. So I'm just saving the object as dt. Once you build the model, the next is basically to, sorry, I have not yet built the model. Let me build the model. Right? How to build the model? dt.fit, feed the independent variables from the training data set and the dependent variable from the training data set. Right? Now, let me just obtain the predictions. Right? Model.predict, if I do, I'll just get all the predictions. You can see how it is predicted. The first flower has been predicted as 2. Second flower has been predicted as 1. Third flower has been predicted as 0. Next flower has been predicted as 2. This is the prediction. Now, whether this is accurate or not, we have to just check. But more than this, what I want to do is basically, I want to basically show you how to display the decision tree. So for this, we have a package which is called as GraphViz. The GraphViz package can be used to visualize the decision tree graph. So let me just go ahead. Let me visualize the decision tree. Let me just visualize the decision tree. You can see export underscore graphics, right? Once I do this, the last step is to basically display my decision tree for iris dataset. So very simple, graphviz.source. Okay, now I hope you're able to see this decision tree.
Yes.
So this is how the decision tree looks like. So we have built a decision tree, correct? If you originally looked at the setosa flowers, you didn't have anything. Just take a look at how beautifully this has come. Right at the top, do you see petal length? Right? Petal length is identified to be the most useful and the best variable to classify a flower as setosa or versicolor or virginica. So what this is saying is basically when you use petal length less than 2.35 centimeters, correct? For a sample of 120, the distribution of setosa, versicolor and virginica is this. So when the petal length, if you just take the petal length and check what is its length, if it happens to be less than 2.5, you can see setosa flowers when you just take petal length of less than 2.35 centimeters. So this is how you have obtained your first rule. We call this as a rule-based approach. What is your first rule? If next time somebody gives a petal, somebody gives a flower, and he asks you, sir, is this setosa or versicolor or virginica? All that you need to do is take a scale and check whether the width is less than 2.35 or greater than 2.35. If it is greater than 2.35, we can't say. If it is less than 2.35, it is basically predicting for setosa. Is this clear?
Uh, yes, it is clear.
Now, this is to the left side. Let me look at the right side. It is false. False means what? There are certain flowers whose petal length is not less than 2.35. It may be greater than 2.35. What then? If the petal length is greater than 2.35, it is not so easy. We need additional information of petal width. So along with petal length, I have to now look at petal width. If the petal width is less than 1.75, then what happens is that most of the flowers, correct, are predicted as virginica. But right, I can't make a decision here itself. Let me go to the left side. Now I have to look at those from among those flowers. I have to check whether the petal length is less than 4.95. Correct? If the petal length is less than 4.95 and the petal width is less than 1.65, you can see here almost all 34 flowers are predicting for versicolor. So it has given different color coding. All the green color boxes are predicting for versicolor. All the blue color boxes are predicting for virginica. And all the, in fact, I can't say all, there is only one. This color, what is this? Can I say that this is brick red? I think this is brick red. This color is used to predict for setosa. Why is it giving you a color differentiator? Because sometimes I may be interested in only setosa. So if I'm interested in only setosa, I look at this box. Sir, I'm not interested in only setosa. I'm looking at others. I'm looking at other colors, which is basically green. So if you are looking at versicolor, you have to look at this box, you have to look at this box, and you have to look at this box. Are you able to understand this, everybody?
Please repeat, sir, once.
So we are trying to identify the profile of the flower. So from the decision tree, what you can say is, if the petal length is less than 2.35 centimeters, almost all 39 flowers are predicting for setosa. That is the first rule. So setosa flowers have a petal length of less than 2.35 centimeters. Is this clear?
Yes, sir, it is clear here.
Now, there may be many flowers whose petal length may not be less than 2.35. Then what? Then it is difficult. We can't make a simplistic rule. We have to go all the way. Look at the direction of the arrow, and wherever the direction of the arrow is going, that is the path that you need to follow. So now look at this. Left side is very clear, I hope. Petal length is less than 2.35. Right side, it says false. False means what? Petal length is greater than 2.35. So we are looking at all those flowers which has a petal length greater than 2.35. When the petal length is greater than 2.35, you have to look at another characteristic, which is petal length being less than 1.75. Further, from among those flowers whose petal width is less than 1.75, you should again look at petal length. If the petal length is less than 4.95 and the petal length width is less than 1.65, let me just look further down. All the flowers are predicting for versicolor. So this is how you can look at the rules in decision tree.
Yes.
Is this clear?
Anyone else can confirm whether it is clear?
Yes, sir.
Now, there are certain things that you can do here, right? Uh, if this decision tree is confusing, we can extract the rules from this. So let me just show you one small step how we can extract the rules. Let me see if the coding, right? I can use what is called as the export text. There's a wonderful function. So let me just write this function. What is this function? From from sklearn.tree, sklearn.tree import. Right, this is the code that I'll be doing. Now, what I'm going to do here is I've created the decision tree model. Decision tree.fit, wherever I run decision tree.fit, decision tree.fit, you can see here dt.fit. I'm just saving this as an object modl. This is important to me. Now, this model, the name of the object is model, so which is what I'll be using now. What I'm going to do now is I'm just going to use a function which is called as export underscore text. This is a function, export underscore text of dt or decision tree. I can put a comma here, and the feature names I have to provide. This may return error. Let me just try this. Feature names. What are the feature names? The feature names will be equal to iris of FEATURE underscore names. Iris may not be the good word because the data set that I was working on is iris in the data. So this is the correct name, correct? So I will just copy the name here and paste it here. Iris in data. It may still throw some error because of some problem. Export underscore text r equals, I'm just saying this is an object. Okay, now a lot of export underscore text feature underscore. I just wanted to extract certain rules for this. Okay, I think I better give this as column names. I just want the names of this. So let me just pick up the names from this. Okay, this is becoming a problem. Okay. Okay, let me avoid that and type R, print of R, print of R. Okay, are you able to see these rules basically? Are you able to understand this? Are you able to see this, everybody?
Yes, we are able to see the screen. Yeah.
Yes, so feature 2 is less than 2.35. What is this feature 2? Feature 2 is basically this petal length itself. So I was just trying to tell Python to give this as feature names as it is, but it says basically, look at this. What it says is basically it is a text-based output. If the feature 2 is less than 2.35, the predicted class is 0. On the other hand, if the feature 2 is greater than 2.35, then you have to look at the third feature, And again, you have to look at the second feature being less than 4.95. The third feature is less than 1.65. Then the predicted class is 1. 1 means basically it is which flower? It is versicolor. So this is the text-based output. This is the actual decision tree-based output. Are you able to understand this?
One doubt that I have. Sir,
What is?
just you keep that classification here, there only, sir. Not here, sir. Let it go up.
Okay.
Sir, from yes, sir, from tree. While getting down from the root node, entropy also it is decreasing little down. Am I right, sir? This is
Yes, you're right. You're right. Yeah, it's a good point. I wanted to tell you, but I forgot to tell you. See, the entropy is 1.581. So
yes, sir.
after, so the variable which has the highest entropy will be chosen first. Then basically petal width, if you look at the entropy, it is 0.99, which is less than the first one. So it is in the
Okay.
decreasing order of the entropy that the tree is constructed. So it is
While in the
0.46.
while in the explanation you say this entropy indicates about chaos in the data. So now while it is decreasing in the decreasing trend, how the chaos it is reducing, sir? Is there any interpretation in the time?
Yes, higher the entropy, higher the chaos, lower the entropy, lower the chaos.
Yes, sir.
So,
So,
entropy is the measurement of impurity, I think. So, at
Yes,
the highest level, we are having impurity. So, by the time we are having subdivision, so we are concluding towards the definitive decisions. That's why the entropy is decreasing.
yes, more the entropy, more the uncertainty.
Yes, sir.
More the entropy, more the heterogeneity, more the impurity in the node. So we are
Yes.
moving from a system of high entropy. Initially, you had 1.5 entropy. But when I look at petal width, the entropy reduces. Further, when I look at one more criteria, entropy further reduces to 0.46. And further, when I look at the next variable, petal width, again, entropy reduces to 0.187. So like this, it will choose the threshold till such time as your entropy is pushed closer and closer to zero. All right. So from a highly chaotic system, we are moving on to a less chaotic system. Less chaotic system means basically make the decision tree as homogeneous as possible. It may not be possible for us to make it completely homogeneous, but as homogeneous as possible.
okay, sir. Thank you, sir.
Okay, okay, okay. So far, is it clear? Is it clear so far?
Yes.
So this is a decision tree that I showed you. If you are okay, shall I show you another example of decision tree? Decision tree. Instead of Google, if you're okay with that.
Yes, sir.
Okay, okay. So I'll just close some of the unwanted files. So can you see this tool here? This is called as IBM SPSS. I can use this to show you a decision tree. Can you see the screen? Or are you unable to see the screen?
Till now, Jupyter Collaboratory is open.
Okay, 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 okay. Now,
Yes.
now you're able to see, right? This is just like a spreadsheet like view it has. It is just like a spreadsheet that you have. So you can see here, this is a tool which a decision tree here, right? This is a lot easier because less coding is involved. This is just point and click. It works like, just like Excel. Okay, very easy. So I don't have to spend too much time in coding and such things. I can just run the algorithm. It saves a lot of time. C drive. I will go to program files. I will go to IBM. I will go to SPSS, statistics 26, and samples, English. And then let me choose tree underscore credit. So this is the data set which I'll be using for modeling. Can you see this data set, everybody?
Yes,
Yes.
sir.
Yes. So you can see here, this is a typical banking data set. So people have given, historically, they've given a rating based on whether you have paid the loan or not. So the first person, if he has sincerely paid, he has not paid sincerely, so it's called as a bad credit risk. First fellow, his credit rating is bad. What's his age? 36 years. His income level is medium income level. He has 5 or more credit cards, and his education level is that he's gone to college, and car loans that he has is more than 2. So if you see here, you have got a few demographic details, right? Second up to the last variable are all demographic and or those details: age, income, credit cards, education, and car loans. And the first variable is nothing but credit rating of an individual. Some of these are bad credit risks, and when I scroll down, you can see some good credit risks are also there. So this is not like iris data set wherein I have got uh, only 150 records. Here I've got a healthy sample size of 2,400 records. So this is my dependent variable. Credit rating, I'm trying to predict whether a customer is a bad credit risk or a good credit risk based on input variables like age, income, credit cards, education, and car loans. Is the problem statement clear to everybody? Is this goal clear? What are we trying to do? We are trying to predict whether a person is a good credit risk or a
Or a bed.
bad credit risk. Shall I go ahead and show you how decision tree works?
Yes, please. Yeah.
You can just see here, click on analyze, then go to classify. Very easy. This is a drag and drop, correct? Not even drag and drop, point and click. Here, when you look at this, there is an option which is called as tree diagram, right? It's a menu driven software, very easy. Just you have to go to analyze, classify, and tree, the way you do in Excel. So let me just click on decision tree. So to the left side, what do you see? You see all the variables. See here, 6 variables are there. Those 6 variables are given. In the right side, it is expecting me to specify dependent and independent. Which is my dependent variable? Can somebody help me?
The dependent variable credit rating.
Yes, very good.
Credit rating.
Independent would be?
All the four
All other.
we can
All other.
All other
Yes,
independent.
exactly. Right. Okay, so this is the dependent, this is the independent, correct? What about the growing method? Do you see the CHAID algorithm here? This is the algorithm, CHAID, CHAID. So a decision tree will be constructed based on what is called as the CHAID algorithm. What is this CHAID? C stands for chi-square, CH stands for chi-square, A for automatic, I for interaction and detection. So the name of the algorithm is chi-square automatic interaction detection algorithm will be used to identify whether a customer is a good credit risk or a bad credit risk. Correct? Looking at the data set, can you tell who's bad and who's good? No, right? Because your 2000 customers is not very easy for you to say who is a bad credit risk and who is a good credit risk. Correct? Shall I run the decision tree?
Yes, sir. So why different methods are used? Somewhere I had read ID3 or CART method is used in decision
Yes.
trees. So is any specific method, or we can choose any
No,
one of?
you can choose any of these methods.
Okay.
Right? I would always suggest experiment with 2 or 3 methods. Let's say decision tree, you can use shade, ID3, cart, any of these methods you can use. And finally choose the model which gives you the best accuracy.
Okay, sir. So
Right?
it means there is no restriction, but which suits your data, we can select the one.
Exactly. You're right. Whichever is giving you the highest percentage of accuracy, that is the champion model. Okay. Firstly, let me go by shade algorithm here. Let me click on OK. So this is the output window. In the output window, when I scroll here, scroll down, you can see the decision tree. Correct? But it is not very easy to understand. So let me just double click and click on the drop down menu and choose 200%. I'm just maximizing this so that it's very easy for you guys to understand. So are you able to see the root node here, everybody?
Yes.
This is my dependent variable credit rating. See here, in the dependent variable, it is saying 42% of them are bad credit risk and 58.6 are good credit risk. So blue color indicates bad, red indicates good. So far, is it clear? This is like a person's head, and this vertical line is like the person's neck. It has identified income level to be the first best predictor to classify an individual as good or bad. Is it
Yes.
clear?
Yes, sir.
Income level. Let me scroll to the left side. Here, within the income level, you have what is called as the low income class. Clear? If you look at the low income class, look at the distribution of bad and good. 82% of the bad credit risk belong to low income class. Is this clear?
Yes.
If I look further down, number of credit cards is identified to be the second best predictor to classify whether an individual is good or bad. So if a person belongs to the low income class and the number of credit cards that he possesses is 5 or more, what is happening here? What is happening is basically 90% of them are bad credit risks. And lastly, age is identified as the last best predictor. Age means what? You can see here, a person belongs to the low income class, number of credit cards is 5 or more, and his age is less than 35 years. 95% of them are bad credit risks. So this is the terminal node. After this, there is no other node. So this is your first rule. If a person's age is greater than 35, you see slightly more mature audience. 78% of them are bad, 22% of them are good. So this is how you can use a decision tree to pick out rules. Is this clear?
Yes.
Now I have gone to one arm, right? If you scroll to the right side, you can see another set of rules here, which means this rule is for medium class, medium income class. Income level is medium. You can see here the distribution itself changes. So mostly medium income class, there 58% of them are good. Now second best predictor is number of credit cards. If the person belongs to the middle income class, number of credit cards is 5 or more, and his age, look at the split here. His age is less than 28 years. Let me scroll down. If his age is less than 28 years, 80% of them are bad credit risk. If his age is anywhere between 28 and 33, 56% of them are bad. If his age is anywhere between 33 and 45, 57% of them are good. If his age is exceeding 45, 85% of them are good. which means basically youngsters less than 33 years, they are dangerous. Above 30 years, by and large, they tend to be safe. That is the message that I can derive from this. So for middle income class, you have one set of rules. For low income class, you have another set of rules. If I scroll to the extreme right side and scroll to the top, you can see the third set of rules here, right? You can see medium income class. Greater than medium means basically rich. So they have their own profile. Now, what is the use of all these things? Now, the use of all these things is you can make this as a rule. You can extract all these rules and maybe formulate a simple if-then condition. Like in SQL, you can give a if-then condition. You can give this to a front office assistant. So a fresh or customer comes in, she can ask the customer details. Sir, do you belong to the low income class? Sir, what's your age? The number of credit cards you have. Based on these characteristics, the algorithm can call him as bad or good. Job done. So if a customer is bad credit risk, don't give him a loan. If he's good, go ahead and give him a loan. Are you clear with this?
Yes.
Right. Now, any model will be accurate or less accurate. So if you want a different representation, correct? So you can just change the layout of this. Look at this. It is just giving the different layout. Bar chart it is giving you. Earlier the layout was different. Now itself it is just giving a different feel of this. Let me just close this. So with any model, you can look at what is called as the risk estimate. Risk estimate is what? You can see here. Risk is 0.189, which means 18.9% of risk is there when you're using a decision tree. Risk means what? It is the chance of misclassifying an individual. When you're using a decision tree model and you go by these rules which I showed, low income class, number of credit cards, age and such things, 18 out of 100 times there is a chance that you misclassify an individual, which means customer may be good, you call him as bad. Customer may be bad, you call him as good. That is the misclassification rate. And you're already familiar with what is called as the confusion matrix. 82% is the accuracy of this model. 81.1, I'm just rounding it off to 82%. So when you're using a decision tree model, there is a 82% chance of your model being accurate. So far, are you clear?
Yes.
Any questions so far?
But on SPSS, it seems much easier then because we need not to do much work.
Yes. So SPSS, yeah. So it's very useful because you can focus on your analysis, not on programming and coding and debugging error and such things.
Correct, correct. Yeah.
Okay.
Yes.
So far,
Sir,
is it clear?
but I would like to say something like I have to select one method, but in Python, what we can do, and for the same data in one go, we can apply logistic regression, then decision tree, random forest, and at the same page, I can differentiate between the efficiencies. Here, I have to go to multiple sheets and then do it.
Yeah, those it
So
depends upon
Python
your
would be more customizable. So pros and cons are there at both the ends, I think.
yes, 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 you're right.
Okay. So,
Right. So to just complete this point, I've just run a shade algorithm and I got 82% accuracy. Let me reopen the dialog box. So shade is one of the algorithms here. In the drop-down menu, you can see other algorithms like exhaustive shade, CRT. CRT means classification and regression tree. And then you have what is called as quest algorithm or quick unbiased estimated statistical tree. So nobody can give you a guarantee saying that this algorithm is the best or that is the worst. We have to experiment and explore, and eventually whichever comes to be the best, that we choose as the champion model. Right now, what we have is basically a shade model, which is giving us 82% accuracy. This is a baseline model. Baseline means this is the first run that we have done. If another algorithm outperforms this, we will choose that as the champion model, right? Or else, let's say we are running cart, that is the challenger model. If the challenger model outperforms the baseline model, the challenger model can be called as the champion model. So let me just experiment with cart method. CRT stands for cart and click on OK. You can see here, this is the method that we have. Risk is basically 19%. Overall percentage of accuracy for a cart model is 80%. So 1% less is there. So earlier when I ran a shade, I got 81.1, 81. So this is not that bad, but it is slightly less accurate as compared to a shade algorithm. So far, you're clear?
Yes.
So I'll reopen
Yes.
the same dialog box. There are other important options here. You can go to output and you can just say statistics. You can just choose the option importance to the model, right? Importance to the model. Independent variables important to the model. And if you want to generate the text output, we were generating the text output in Python. You can generate the text output either in SPSS format or SQL format or simple text. I'll just
Sir, may I ask a query here?
yes, please, yes.
Sir, when we use these decision trees and other things in Python, we can, after creating the model, we can predict the value of a test variable. So,
We
is
can do
it
that here
possible
also.
to do the in this
Definitely.
SPSS also?
Yes, yes, yes. Easily, easily.
Okay. Okay.
Correct. So we are saving these rules here. You can see here, I'm just saving these rules in desktop. Let me continue and then let me click on OK. So this is my cart model. This is the data set. A risk is basically 80%. You're also getting additional input here, like which are the most important drivers of credit risk. You can see here, income level is the best predictor. Therefore, it has a long bar here. You can see here, approximately 13% of 13% is the contribution power of income on credit rating. Next important variable is number of credit cards. Nextly, we have age. Next, you have car loans and education level. These are the top 5 drivers of your uh, of your what shall I say credit rating behavior. So this is one additional output that you can get. That is the variable contribution. You can see here in the desktop, I have created rules here. So this will come in the form of, you can see here, these are all if-then statements. If income level is not missing and if the income level is low, then the and number of credit cards, right? What is this number of credit cards? You can just see here, and number of credit cards is 5 or more, or number of credit cards is not less than 5, and the car loans is not less than is not equal to none or 1, and age is less than 36.8. It gives you so many important rules. Then the predicted category is 0. 0 means he's a good credit risk. What is the probability? There's a 98% chance that people with this characteristic, this means income level, whatever we are reading, people with this profile, there's a 98% chance that they will not be defaulters. So next time a fresh customer comes, I can look at his profile, compare it with the rules that is extracted here, and basically decide whether he's a risky customer or not risky customer. Are you clear with this?
Yes.
right? Like this, it has extracted many rules. You can see here, though so many rules, it is basically extracted. I'll just close this. Let me just to finish this point. So right now, shade algorithm is the best. We have experimented with cart. Cart is not that good. If you want, you can try with exhaustive shade. And we can see the accuracy level is 81.1, which is the same as the shade algorithm itself. Finally, what we have is basically, you can look at the quest algorithm. Quest stands for quick unbiased estimated statistical tree. Let us just try this as the last type of decision tree. I can scroll down. The accuracy is just 80.4, which is less than the shade algorithm. And therefore, for all practical purposes, after experimenting with 4 algorithms, I can say that my decision tree algorithm is my decision tree algorithm, which is shade, is the best model that we can build. Are we clear with this? Are we clear with how decision tree works?
Yes.
So this is a typical decision tree classifier, wherein the dependent variable that we used was a categorical variable. You can see here bad or good. If there are any questions, you can ask me, or else I can just show you decision tree regressor, how you can use decision tree for regression purposes. If there are no questions, I can just remove this data set.
Yes, I think yes, no question. Anybody is having any questions?
Okay, let me just, I've given you iris data set. Then I went to credit risk. Now I want to give you a retail example. In retail data, how it can be used. So file open data. Let me just go to a file and pick up some sample file. Program files. IBM, SPSS, statistics, 26, samples, English. And here I can use a new file, which is called as grocery underscore 1 month. So basically people are going to your supermarket or one of these retail outlets and they're buying grocery items. So we'll work on this. Can you see this data set?
Yes, yes, we are able to see.
So that typical, yeah? Which store has a person gone to? Is he buying healthy food or not? The size of the store, organization item, what is the customer ID, his gender, who is he shopping for, is he buying vegetarian or not? Then you have style, right? Right? Is he buying bi-weekly or not? Usage of coupon is there. Amount of money spent is there, right? So all the other variables are not useful, so I can just delete it. So you can see here, amount of money spent is my dependent variable here. Why? Because it is the most important variable which will help me understand whether a person is a profitable customer or not a profitable customer. So here is the dependent variable categorical. My dependent variable amount of money spent is not a categorical variable, it is a scale variable.
Yes.
Are you able to understand this? So here we can use a decision tree regressor. Just go to analyze, classify and choose tree here. Again tree. Dependent variable is amount of money spent. And the independent variables, some sensible variables I'll take. Healthy food, size of the store, customer ID I can ignore, gender, who are you shopping for, vegetarian, shopping style, usage of coupons. So here, that is why I was saying that dependent variable can either be categorical or it can be continuous. Same thing with independent variables. It can be either categorical or numeric, but decision tree supports both of these things. So when you have a continuous dependent variable, it is called as decision tree regressor. It is called as decision tree regressor. Let me now click on OK. Are you able to see this output?
Yes, yes.
Do you notice any change here? See, when we did in Google Colab for Iris dataset, entropy was used. Based on the decreasing order of entropy, decision tree was constructed. Then we came to IBM SPSS, we use CHAID or chi-square automatic interaction detection. Chi-square statistic is used. Now we are using dependent variable which is scale, and therefore mean value is used. This is simply using mean value. So for an average customer, the spend is $400. Any customer who is coming to the shop, right, he is spending $400. Now, who is a more profitable customer? That is the question here. How can I call a person as a more profitable customer or a less profitable customer? Any idea? How can I call a person as high profitable or low?
On the screen is gone, so yes, now we can see.
So here, when you look at this, right?
Yeah. Yes, yes.
Average customer is 400. If any other customer or profile of people spend more than 400, 400 is the baseline amount. So average customer anyway is spending 400 rupees. If somebody is spending more than 400 rupees, he is profitable. On the other hand, if he's spending less than 400 rupees or dollars, whatever the unit, I don't know here, I'm thinking it is dollar. So it is, if it is less than 400, he is a low profitable customer. So if I have to spend, if I have to, market expensive products, I would be looking at high profitable customers or more big buyers, big spenders rather, right? If I want to sell cheap goods and such things, I can look at those people who are small spenders. Either a person is a big spender or a small spender. Let us look at the profile of who is a big spender, right? Bigger than 400, that is the baseline. So your target itself is 400. Above 400, profitable. Less than 400, cheap. Close to 400, is a typical average customer, correct? So let's look at this decision tree. So most important reason is, who are you shopping for? Look at this. This is what we saw. If you're shopping for yourself and family, just visualize, if there's a person who's coming and shopping for his entire family, not just for himself, his wife, and let us say 2 kids, obviously the amount will be higher because he's shopping for more number of people. So the average spend amount of such a group of people is $504, which is almost $104 over and above your average customer. So you have your first set of customers. That is, if a customer is shopping for himself and his family, he's your ideal customer who's spending a lot. So treat him with respect. He's your gold. He's the most valuable customer that you can think of. Now, on the other hand, let us look at self, people who are shopping for themselves. Maybe they're bachelors, they're unmarried, and such things. Their average spend is less, is 342, which is less than the baseline amount of $400. So we can't make a decision based on self. We have to look at gender as well. He's a person who's unmarried and he's shopping for himself. If he's a male customer, his average spend is 382, which is still less than the baseline amount. And if it's a female customer, it is still worse. It is $300 only. It is very, very low. So men who shop for themselves, they are cheap customers. Similarly, women who shop for themselves are again low spenders. You can call them as low customers because they are not really spending a lot of money. Now, this looks quite interesting because look at this. This is 401. What is the profile of, what is their story? Let us look at them. So, look at the reason for shopping. Who are you shopping for? This is very interesting. You're shopping for yourself and spouse. And if a person's gender is male, on an average, he's spending $401. $2, slightly less than the slightly less than the average customer, right? But it is not a overwhelming number. It is not as big as 504. So though they are, I would not call them as very profitable customers. I would still call them as baseline customers. On the other hand, if you're a female and you're newly married or whatever, and you're shopping for yourself, you're spending $356, which means you're less profitable as compared to your male counterparts. This is one more decision that we can make. So this is a typical decision tree regressor. Now, because we are building a regression model here, right? Because we are trying to predict here, you can just see here, you will not get a lot of classification metric and such things. It is just saying, right, what is the risk of estimation, risk of misclassification? Approximately $4,854. On an average, to the extent of $4,800, you may miss you may mispredict. You may make a wrong prediction to the extent of on an average of $4,800. So look at this: node 2, node 6, node 4, node 7, and node 8. It is giving you the average spend amount of 504 and 401. So only the first two nodes, namely node number 2 and 6, these are the only two profitable segments. The rest of them are below 400, and therefore there is no use looking at node number 4, 7, and 5 because they are actually customers who are not profitable, they are small spenders. So this is how you can look at the gain summary chart here, gain summary table here, to identify the performance of a decision tree regressor. Yeah. Are you clear with this?
Yes. Yeah.
Any question here?
So that means with the gain summary, we can find it out the all the outcomes.
Profitable customers.
Profitable customers, yes.
Yes.
And yes. So then the risk is given below. So how to interpret that?
So the risk of here you're trying to find out the what is the average what is the average amount to which you can go wrong? I'm saying that a typical customer may spend $400,
Okay.
but he may actually spend only 350. So
Okay.
350 is his amount, but my model is saying 400. If you take the subtraction of 350 and 400 is $50. So here, when you're using the overall risk estimate, it is saying that on an average, $4,800 would be the miss. It will be the wrong prediction amount that you can get.
Yes.
4,800. So it depends upon the business now, right? Usually, is this a good model or is it a bad model? That's a question, right? 4,800 in the sense, can you afford 4,800? I don't think so. Ideally speaking, if it is in double digits, it is better rather than $4,000 in such things.
True. Yes.
So here, because the dependent variable scale, we are not getting a classification metric, correct? If you were to build a classification model, you will get a model like this. If you build a classification model, this is a lot easier to interpret because you're getting a confusion matrix, and we have seen how to interpret this. Here again, one important consideration that is, see, 81% is the overall percentage of accuracy. Many times we are not interested in overall accuracy and such things. Why not? Because there are two categories, bad and good. Now, always you have to make a decision. You have to take a call here. Who is more harmful to the customer? Is a bad customer harmful or is it a good customer harmful? Is a bad credit risk harmful or is it a good credit risk harmful? If you look at a bad credit risk in the earlier case, 70% is the accuracy, not 81%. So your model is doing a good job of only 70% in identifying a bad customer, 70%, which means out of 100 bad credit risk individuals, 70 have been correctly identified, 30 have been misclassified. The question is, as a business user, are you happy with this model? Statistically, is it good? Yes. Any number which is greater than 50%, if the percentage of accuracy is greater than 50%, then you can consider it, right? So here 70% is the accuracy for predicting bad customer. Now, when it comes to predicting good customers, 89% is the overall percentage of accuracy. 89, right? So in identifying whether a person is good, 89% is the percentage of accuracy. So your model is actually learning the characteristics of good customers, not really the characteristics of bad customers. But we don't usually pay too much of attention to good customers because they are harmless. I'm more interested in identifying the characteristics of bad credit risks. So if you take the average of 70 and 88, it will come somewhere around 81. So which is the overall accuracy. So though we look at the overall accuracy, it's always the accuracy of the harmful category that you should be mindful of, not the percentage of accuracy for harmless people.
True.
Okay.
Yes.
Now, which one do you consider? So a lot of people ask, which one should I consider? Should I consider 70%, 80%, 81%, 90%? The answer I'd like to give you here. Now, imagine, now we are talking about a banking and such things, right? Now, if you're a startup company, you're just now begun, you're opening your eyes in the market. This is the first year or second year. As it is, getting customers is difficult, right? On top of it, if you put a lot of pressure and such things, you should be good, you should start verifying the documentation strictly, then your customer base, not many people will join at all. So it is not a very profitable business at all. So if you're a startup company, then identifying the profile of bad credit risk is a problem for you.
Yes. True.
Right. In fact, I would say if you're a startup company, I would say basically you sometimes it depends upon what is the risk appetite that you have. There is no one universal risk number that anybody can quote. If you're a startup company, you may still slightly, I don't know, it just depends on the risk appetite. Sometimes you may overlook certain considerations and such things, and you may still allow people because you are more hungry for customers. I want to expand my customer database. I want to expand my footprints in the business. I'm struggling to get every customer. So I may slightly be, I may slightly be lenient on risk category and such things. I may not, I may still allow bad people under certain circumstances. On the other hand, let's say you're already in the field, you're a big player, you already have a footprint in the market, you're not so desperate for customers because you already have a healthy customer database. So you have 20 to 25 years of 20 to 25 years of strong, solid customer database. So when you have 20 to 25 years of strong, solid customer database, here it becomes a question of your reputation. So you can't have too many NPAs, non-performing assets, bad debts, and such things. There you may be very, very strict with bad customers. So it depends upon a lot of business considerations. No, don't just look at data science metrics. Data science metrics are important, but business metrics also become very, very important. If it's a startup, sometimes you're hungry to you want to expand your customer database, so you may be slightly lenient in the initial period. But as the number of years pass by, you tend to be more and more strict because you don't want to accumulate a lot of bad debts and such things. So that depends upon the overall experience and the growth of the company as well. That is what I wanted to say. Any questions, please ask me.
Yes, one question is coming that can we give input Excel file for this software? So
Yes, definitely. It can read files from any file, any ODBC connectivity, right?
How, sir?
It can read Excel files. It can read CSV text file, text in the sense CSV or tab delimited file. You can also pull in the data from SQL and such sources. No problem. Please ask.
um, Ankit wants to know about cart again. More clarification on the cart.
Okay, cart. So firstly, what did we do? We ran CHAID. Let's understand CHAID, then cart becomes easier. So look at this. This is our CHAID algorithm, correct? Here, in the case of CHAID, basically, chi-square is used to grow the tree. You can see here, chi-square statistic is used to grow the tree here. Okay. This is your typical CHAID, and you can see multiple splits here, right? You can see here low, so this is about your CHAID. Then basically, if I come to your another type of decision tree, this is your cart. Here you can see only binary splits. So cart is good, but it provides only binary splits. Cart is good, but it provides only binary splits. Here, if you look at the model, it is going by a statistic which is called as improvement, right? It is using a metric which is called as improvement to grow the tree. So firstly, the improvement level is basically 0.09. Then if I scroll down, the improvement level goes down by 0.01, 0.09, it reduces to 0.016. Then further the improvement keeps going down. So higher the improvement, better the predictor, and such a variable will be included at the top. So CART, to put it in simple language, CART stands for classification and regression tree. The metric here is basically improvement statistic. And let me just share it with you. Are you able to see Google? I'm just opening a Google sheet here. Able to see Google?
Yeah, we are able to see.
So you can just type CHAID versus CART here. There's an interesting comparison between shade and cart. You can look at this. So they have compared cart C4.5 and ID3, I think. Mm, See here, type of data, it can handle both continuous as well as nominal attribute data. When it comes to speed, it is average. ID3 has the least speed, but C4.5 algorithm is faster than ID3. When it comes to boosting, boosting is not supported, but CART supports boosting. Boosting means improvement of the accuracy level. So pruning is there. Missing values, how it can treat? It can deal with missing values. The formula that it uses is what is called as, it uses Guinness index. So if you want to read this and explore this further, I'll just share this link with you so that you understand in a deeper way about CART. Is this clear? Are you able to follow CART, sir? Binary splits, it goes by Guinness index, right? It is fast, and it can also, you can also use it for boosting. It can handle missing cases. So this is how CART works. Is
And
it clear?
talking, yeah, yeah.
So in
Yes.
cart, random forest is applicable since you have said that boosting is there. So which type of boosting?
No, boosting can be supported. Now, random forest is a different algorithm altogether, because when we say random forest, multiple decision trees can be are used and combined to form a random forest.
Okay.
So random forest is not exactly a boosting technique. Random forest belongs to another class of techniques which is called as bagging.
Okay.
Random forest belongs to another type of technique which is called as bagging technique. So forest means what? I mean, it's just an example. Forest is a metaphor. One is basically in your home, you can have one tree. On the other hand, you can have, if you go to a forest, you can have thousands of trees. So in the same way, they've used this as a metaphor. So decision tree is one algorithm. In the case of random forest, multiple trees are grown, and finally you aggregate multiple trees and you get one consolidated output. So random forest output will be more robust. It will be robust. Decision tree, I told you, it suffers from the problem of overfitting. How do you correct for the problem of overfitting? You can use what is called as random forest.
Okay, sir.
Now talking about the Gini's index. So like Gini's index is also being used to, suppose we want to know the distribution level of income among certain geographic area or certain country. So there also it is used. So how, like, okay, earlier also, like you have discussed about the Gini's index, like in the beginning. So can you throw some more light onto this on the, while using the Gini's index along with this decision tree?
Okay, Gini's index actually is a measure of, it is used in the context of economics.
Correct. Yeah, yeah, yeah.
For income inequality and such things.
Right, right, yeah, yeah. Especially the nations, we want to know that, okay, which nation is having the equal distribution of income. So there, like, it gives a lot of decision making is done based on that.
Let me just try
Also, the
to.
corruption
Yes,
level also we measure with that.
yes, yes,
If
yes,
we
yes.
want to know the which country is more corrupt, so then we use the Genius index.
It has a lot of application in income inequality and such things.
Correct, correct, correct. Yeah, yeah, yeah. So if we understand that using the Genius index along with the decision tree, I think we can, the researchers can have much more problem solving.
Yes, yes. So let me just close all these things. So this is where he's discussing about entropy.
Okay. Yeah, yeah, yeah.
Minus P log P, minus P log P. Okay.
Yes.
Okay. Guinness quotient also. He has not discussed.
I think somewhere you spoke about this in the beginning. So
Yeah.
and yesterday you also like you wanted to do some problem solving with this Google this thing. Uh,
Google Colab.
Google Collab. Yeah. So application of Google Collab also that also you can tell them something more.
Yeah, that's what we did actually. Sample values and Gini. Okay, here we have.
This is Anjani. You have taken.
So a node's Gini's attribute measures its impurity. A node is said to be pure when all the training instances it applies belongs to the same class. For
Okay.
example, we see that in the class Iris Satosa, Gini appears to be 0, which means it is pure. So a Gini value of 0 means it is pure. A higher
Yeah.
Gini value basically means it is impure. So and
Right.
he's also giving you basically the formula to calculate the Gini. So sum of P into 1 minus P, that is what he's saying.
Okay.
P times 1 minus P. P is, I think, probability of success here.
Probability.
Yeah, so he's just taken the root of Gini here.
Correct.
Gini of 0 is basically pure, and Gini of higher value basically means it is impure. That's it.
That's so.
So tomorrow, mostly we'll be looking at unsupervised learning technique. Today we spent one example on nonlinear technique. Tomorrow we can look at some of the unsupervised learning. I will be doing market basket analysis using R tomorrow.
Okay, that is the market basket analysis. Yeah.
Yes. So there's an algorithm called as a priori algorithm, which I wanted to show. So I'll try to show you a priori algorithm.
Right. Yes. Yeah.
Okay.
So yes. So if anyone is having any more questions or doubt, we can take it ahead. Or any comments somebody want to make. Yes. So I think Mithun, it has been a wonderful session. So the people have understood about the application of the decision tree.
Okay, great, sir. Fantastic.
Okay, so finally now we are coming to the end of the session. So once again, we would like to thank Mr. Mithun that he has given shared his knowledge, and we are now empowered with the knowledge of the decision tree and the various tools which he has discussed. So thank you so much, sir, and then we'll again look forward meeting you same time. That is, I'll request all the participants to join at 6:50 as usual that we join every day, and then maybe in 10 minutes all others can join. So thank you so much, and wishing you all good luck and very happy learning ahead in the coming weeks. Okay, so thanks a lot. Thank you, Mithun. Thank you, everyone. Thanks, everybody, all volunteers. We'll meet again. Thanks a lot.
Thank you so much, sir. Thanks to all the participants. Good night.
Good night, sir. Good night.